So there's another way of dealing with multi-valued functions which avoids the issue of branch cuts, and that is to use something called a Riemann surface to represent the function. So what happens with a Riemann surface is that when you would normally have a branch cut, you instead, what you do is you say, well, if I've got a multi-valued function which has say n different values. So for example, if you've got the square root of 2 which has two possible different values, then you have two what are called sheets. So basically I'll illustrate what happens. So suppose you start off with z here. So I'll just say at this point here z is equal to e to the I 0, just keep things simple. Then as theta increases, I move around here and I'll say at this point here z is e to the I pi. Now when you reach this point where you would normally have a branch cut, what you do is you jump onto the other sheet. Okay, so at this point here I go round this. At this point here z again is e to the I pi effectively. Then I go round here, z is e to the I 2 pi. Remember, if z is equal to e to the I 2 pi, then that means that z to the half is just e to the I pi. Then I go round this sheet until I reach where I normally have a branch cut, and then I jump back. So at this point you've got e to the I 3 pi. Then I jump back to this sheet, and z at this point is e to the I 3 pi, and I just follow it right the way back until I'm back here where z is e to the I 4 pi. Now what's the significance of that? I've sort of double counted the angle, because as I move around I keep on increasing the angle. Okay, so there's no discontinuity in the angle. I keep on increasing the angle. When I reach this point here, I just jump to another sheet. Now if I can imagine this sheet being connected smoothly with this sheet here, and I go around here and then I jump back to this other sheet which is connected smoothly here. Now this is impossible to represent in 3 dimensions. We just have to imagine that these sheets sort of pass through each other and don't notice. But basically I'm just saying the jump is smooth. I go back to here. Now when I'm back to here, I've got z equals e to the I 4 pi. If I take the square root of that, I get z equals e to the I 2 pi, which is the same as e to the I 0. So there's no discontinuity. I've done everything completely smoothly. So I've got rid of any discontinuity by using 2 sheets which are connected in a clever way.